Hello, we're starting today's session. Today's session of Python Advanced training. We're going through the session today. Today's day two. This is a 4-day training section, and my name is Anand. I have over 16 years of experience working on data management, data analytics, data visualization, data automation, data integrity, and data science. Um, I have uh, uh, I have a good experience of using Python to get a lot of data integration, data analytics done. So let's see what we covered previously. Previously, we covered list comprehension and other comprehension that Python provides. Um, we also touched upon how we can use the map, the filter functions. We went into a little bit of um, reduce and a little bit of zip function. So we'll continue with that. So today's session we'll go through um, the zip function mainly. The reduce function we'll touch upon a little bit later. We'll do about 25% of the session with Lambda and the um, remaining part of it with magic functions or Dunder functions. So those are the topics for today. Um, So the remaining two sessions that we have for this training session will be covering the generators, decorators, and hashability. So those are important concepts that you need to know when you're going into advanced Python concepts. So let's dive in. The first one we are looking at is the zip function. Um, the zip function is used to create a tuple with multiple iterators. Say we have like two sets of numbers. Let's say num1 and num2, and each is a list of say integers, say 1 to 3, and another one which says num2, which has all the like even numbers, say 2, 4, 6, 8, and so on. Notice that the lengths of the two um, iterators are not the same. Um, if we want to use um, use a function to get a tuple of the first element of the first list and the first element of the second list, and we want to create something like a 1 2, a 2 4, a 3 6, um, then we can use the zip function. So let's try that. um, let's do list of zip of num1 and num2, and let's print it up, and we'll see what that's gonna do. So what we get with the zip function is a tuple of 1 2, 2 4, and 3 6. So to get these multiple tuples, the zip function is very useful. Um, this is in, uh, in a lot of cases where we have multiple iterators, whether it's multiple lists or multiple tuples. This would be a very useful use case. Let's do the same with like strings, and instead of lists, let's use tuples. So let's say the case is this. Um, we have two lists or two tuples. Yeah, let's take the example of three tuples. So we have three tuples. They are of the same size. They have names. and they have if we want to zip them and we want to print the list of uh, them, or let's say a tuple, we build a tuple with the zip function result. So if you want to do that, um, then that should give us a tuple output with three elements in the first tuple, which is John, Jenny, and Johnny, which is the first elements of this A, B, and C. The second one is Charles, Christy, and Charlie. So the second elements all come together in one tuple, and Mike, Monica, and Mikey, they come out of the third tuple. So this way you can use the zip function. The next and very, very commonly used um, like interview question for a lot of Python Python interviews is the Lambda function. Um, so the Lambda function is anonymous function. Um, the reason it's called an anonymous function is because we don't define the function using the def statement, and when Python references it back, like so, say when we go back to the memory location of my func and we print that, it doesn't. So in this case, we're not using a diff function. In this case, we're actually using a lambda function to define the function. So in this case, the my func is defined not as a function but as a lambda, so it doesn't have its own it's defined differently, and it's not having its own named space. That's why it's an anonymous function. um, but how do you use a lambda? So like lambda has arguments and an expression. So when you want to use a lambda, this is the argument that you provide. So when you call my function within parentheses and you provide one input, this is the input for that, and the expression that comes out of this would be this. So in this, let's say we just want to add one. Whenever somebody gives in a number, we want to add one and provide the output. So in this case, I'm going to say I want to add 1 to 5, and then I want to see the output to be 6. So anybody else calls this function with 9, they get 10. So I want this lambda function to be able to provide a number that's one more than what is provided. So let's use this lambda function. So this is the input of this function. So this goes in here, and this is the output. Say if you want to execute this, note that I've already declared a to be 1, but whatever is used here as a is a local variable within this lambda function. So it does not matter that it's already been declared. Like a does not get changed after this. If I print a post the invocation of this function, so here when I print this function, I call the my function, and then I pass the value 5 into this a, and then it returns back a plus 1, so it returns 6. So this would actually return a 6, but this a has initially a value 1. Even though I'm calling this with the same alphabet a, it does not get changed, and when you print it, you should be able to see the value 1 there. So this is still 1, and it does not get changed. Say I want to use two parameters in my function, and I want to add or multiply the two numbers, and I want to multiply 5 and 10, 5 and 2, that gets me a 10 here. So when I go back to the lambda function, I define this with two inputs. So let's say x and y, and then let's say you want to multiply x with y and return that. So in this scenario, this is equivalent to doing def my1 and then saying with an input x and y and returning the value x multiplied by y. So this myfunc1 is equivalent to myfunc. So those two are definitely equivalent. Um, they do the same things, but this is defined as a function while this is a anonymous function or a lambda. So let's try invoking this. Let's try invoking my function 2 with two parameters 5 and 2, and with two parameters we return the value x multiplied by y. So we see that it provides the value 10. Say I have a value x as 1 and y as 7. If I want to pass only one value to this, but I want this to have a multiplied by another number, but say y is a global variable. So when it comes here, it still has the value 7, and I am passing only the value x as input. Now I want to provide the return value as x multiplied by y. So let's try that out. So we get the value 35. So here y is not even provided as an input parameter, but because y is a global parameter here, it takes the value from here and uses it. But for x, because it's an input, it uses this value, it does not use the global value of. So those are some of the information that you would need to understand on lambda functions. I'll get to where we use lambda functions, but as of now, remember that we use lambda functions for like pretty simple one-line um, executions, and also where we don't reuse it multiple times. Say if we have to use a function in multiple places, then we rather define the function. And if say it's a complex execution of multiple lines of code, then we rather define a function. When it is quick, then we use a lambda function. But there's also more to it. A lambda function, like certain higher order functions, take functions as inputs. So that's the place where we really want to use lambda functions. So the lambda functions are very useful when you know about higher order functions and you want to use them quickly. And it's also used for quick one-line executions of functions which are not repeatedly used multiple times. But those are essentially where it's used. So here we know that when we define this as a function, my function, then we can actually invoke it and then call it using the parenthesis. What if I don't want to really reference it? I'm just going to use it like once, not going to use it ever. How do I use it? So you can enclose whatever the whole lambda statement into parentheses and then invoke that with this. Say for example, you want a number. Whenever somebody sends you like provides a number, you want that to be multiplied by 9 and divided by 5 and then subtracted 32 from that, and you want to make sure it's a float. Say you wanna write a quick equation. So whenever somebody sends you a value, you multiply that by 9 by 5 and then subtract 32 from it, and you want to return that value. Say say you pass in the parameter 32, um, and then you try to, or let's say you pass in the value of 32. Let's do this. So let me do this. Let me first subtract 32, and then let me multiply by 9 by 5, and then I'll pass the value 32. So what would happen is it gets converted to float and subtracts the value 32 from it, then multiplies by 9 and divides by 5, and that would be the output of this lambda function. So when I invoke this using this, the whole lambda function is not stored into a name called my function. Like here, it's a variable my function, and then that gets invoked here. But here, we're not even storing it anywhere. We're directly using the lambda function within parentheses and then like calling it directly. This doesn't ever get used. Say if you want to convert a temperature that is 70 degrees, then you want to do that. So that's 68.4. I don't think the formula is right, but yeah. So this function works as intended. So it converts into float, subtracts 32, multiplies by 9, and divides by 5. So all that happens here. Where do you use this? I like in my professional programming life, I have never come across using lambda functions in this way, but it is a possibility though. So we can use it this way if needed. As we did earlier, we can also name it, and then we can use it once. This as well, I don't see it being used regularly. So the typical usage though, you can name it and use it, and also use it unnamed. But the typical usage though is for certain other places. When you want to do any trivial task, not much complexity, use an anonymous function. Say example of converting Fahrenheit to Celsius. That's a one-line equation. You could do that. When the function has a single expression, so it can be a long expression with like multiple and statements, or like multiple addition statements, but as long as you can put it in one expression, then you can use anonymous functions. It doesn't have multiple if conditions, and if it's this way, then it return this. If it's this way, then return this. If you don't have multiple conditions there, then you can use it in one expression, then use anonymous functions. Um, for any repetitive task that's temporary in nature, say whenever you have repetitive tasks, you would rather use a function for it and define a function. But say in certain scenarios, you don't want to define the function because it's a temporary function that's going to get used only in this module. For those repetitive tasks, you can use an anonymous function. When you want this function scope to be limited only to the current scope. So when we're talking about scope, I was showing up those global variables and how you can just have a limited scope for certain variables and then use that just there. So when you want to have the functions to be in very limited scope, then you can use a lambda function. Those don't have a global scope. More usefully, the last two bullet points, that's where it gets used very regularly. The first few bullet points, I've used it in regular like coding, but those are like only for very, very simple operations. But when we want to use it along with map, filter, reduce, we use the functions a lot because these are higher order functions. For map, filter, and reduce, we provide an iterator and we provide a function. So the function itself is an input. So like instead of writing a function and providing that as an input, you could rather, if it's a very simple function, just use a lambda and provide that as your function and do the reduce. Yeah, we covered map and filter and a little bit of reduce last week, in the last session, I'm sorry. Yeah, so we did cover that the last session, but essentially what map, filter, and reduce does is map can take a list or any like tuple or dictionary, and then it can process a function over it. For map, what it does is it it provides, I mean, it takes in a list as input and processes all these elements through the function and provides the output as another list. For filter, it checks the function only if it returns true. Like if there are 10 elements in the input list, after filter, only 5 of them like meet the condition and the function actually returns true, then the filter would actually return only those 5 elements. And for reduce, what it does is it can like combine the multiple elements of the list into one output. Say you want to add all the elements in a list, then you can use the reduce function. So those are cases where you would need function as an argument. In those cases, if your function is pretty simple, rather use the lambda function. You don't have to create a function for that. I've seen this used in sorted, min, and max. Um, Not only in practical purposes, but in interview questions, this is a very, very like regularly asked interview question. You could see it a lot in lead code. You can see it a lot in so many interview questions that Amazon asks or Google asks. Let's look at a list of numbers 1, 2, 3, 4. Let's see how we can use map and provide a lambda function instead of a function here. Instead of providing a function name here, which gets invoked, we can actually provide a lambda function and then use it. So let's try to do this. So we have a list of numbers 1, 2, 3, 4, 5. Now what I want to do is I want to like add 1 to each of these numbers, and or let's add 2 to each of these numbers and provide that as output. So what we do is we build a quick lambda function. The map takes the function as the first parameter and the list as the second parameter. So for this list, we provide list of numbers that we have there. And for the lambda function for adding 2, we take x as input and each x becomes x plus 2. So when we actually provide this out, when we print this out, we get a list which has 5 elements, and all these 5 elements would be added. Like 1 will become 3, 2 will become 4, 3 will become 5, and so on. So let's check that out. So we get the elements 3, 4, 5, 6, and 7. Say we want to print only the odd elements. So we want to use filter. So filter, what it does is it checks for the elements and only provides the one. Say you want to you want to filter the ones which are actually odd. So what we do is we use the x mod 2 and we check the ones that are which provide the remainder 1. So those are odd numbers. So in this lambda function, so we take x as input. So each piece of this list goes in as input, And whenever this expression returns a true, that's when the filter would actually get that output listed out. So let me try that. So in this case, what happens is 1, 3, and 5 match our criteria. Those are all odd numbers, so they come out. Those are output. Then we look at reduce as well. So reduce, we have to actually import from func2, and after that, when we use the reduce, in this case we don't have to use a list function because the reduce returns only one variable, which is which is either an int or a string or one or anything, but it's not a list or a tuple. So it's not a iterator. So like we get just one value out. So in this case, we don't have to use the list. So we call the reduce function. The first parameter again is the function. The second parameter is the list of numbers. And for the function, we're using a lambda function here, and we're taking two inputs. And in this case, what reduce does is reduce adds the previous element to the current element, and then keeps that value as the new element. And then next time the second element comes, it gets added to the next element, and then it does it and so on. So what would happen is we'll get the sum of 1, 2, 3, 4, and 5, which would be 15, or let's make it just 1 and 2 to see if we get 3. And if we actually add back all those numbers, we should get a 15, which is the addition of 1 plus 2 plus 3 plus 4 plus 5. So that's what we use lambda functions for when we use map, filters, and reduces. The next piece I was talking about is the sort and the sorted, the min and the max. So I'll show you one example with sort. You can understand how similarly min, max would be used. These are typically asked very much in interview questions. Let's say we have a point and a list of points is listed here, and each point has a x coordinate and a y coordinate. So this is a list of dictionaries. Each dictionary has a x coordinate which has the string x is the key, and the value is the x coordinate, and y as the key, and the value is actually the y coordinate. So we have 2, 3. So this is the point 2, 3. This is the point 5, 2. This is the point 4, 1. Say I want to sort it based on the x coordinate. So I want to know which ones come earlier in the x coordinate. Then if I actually run a sort here, it would actually fail. And the reason is it would, like, within this list there are 3 dictionaries, and Python would not be able to like sort the 3 dictionaries. So to be able to change how the sort does, we have to provide a value called key. So we provide a value called key and tell it what the key is. And to tell it what the key is, we don't know what this element is, and within the element we want to be able to say get the x coordinate of this and then sort it based on that. So to do that, we're actually using a lambda function. So whenever it gives me a value I, or this piece, this dictionary, I wanted to sort it based on I of x. So I want to get the value of 2, 5, and 4, and then sort it based on that. So I should probably get the 2 first, then the 5, then the 4. I also would like to try if I can do it based on the y coordinate. So I use the same lambda function. I use I of y, and then I sort it. So this sorts it in place. You know that the sort function does not return anything, so I cannot print this. So I'll have to print the original array, list itself. So I am going to try that now. So in this case, what happens is it sorts it based on 2, 4, and 5. So the x coordinate is 2, 4, and 5. In the next scenario, it uh, sorts it based on the y coordinate. So the 1, 2, and 3. So it gets me the 1, 4 first, 4, 1 first. Sorry, the 5, 2 next, and the 2, 3 next. So it provides it in the order of y coordinates here, provides it in the order of x coordinates here. So let's see how we are using the lambda function here. We can do it. This question can be done without using a lambda function. The first solution I got was not using a lambda function. I was actually using um, list comprehension that we were talking about yesterday for this question. And then I realized there's probably a slightly better way to do it. And then I was able to use the sort and then do it, and then use a lambda function for it. So essentially this question is, we're given an integer array, nums, and then we want to move all the even integers at the beginning and move all the odd integers at the end. They don't like really mind if you have it in different orders, if you resort it or reorder it. Say if the input is 3, 1, 2, 4, and the output they want can be either 2, 4, 3, 1 or 4, 2, 3, 1 or 2, 4, 1, 3 or 4, 2, 1, 3. Any of those is acceptable. So they don't actually mind what order the even numbers itself are rearranged in, or if the order of the odd numbers are rearranged. So in this case, the solution I first went for was to return two lists and then add them up. So what I did was n for n n nums if n percentage 2. So to be even, it has to have a remainder of 0 when divided by 2. So I did that, and then I got all the odd even numbers up front, and then I did a plus operation, so the list can actually do a plus operation. And here I just added all the ones that have all the ones in the list that have a remainder of 1 when we actually print it out. So when I did this, it provided me whatever I needed. So it pulled all the even numbers up front and it pulled all the odd numbers up to the back. But there is a slightly better solution in the sense that we don't really need to know like all the information, and we don't need to go through all of them and then like sort it, like split it into two and then add it up back. So we don't need to actually have two different lists and then add them back. So we don't have to do that. All we need to know is if this remainder is 0, I want those up front, and if these reminders 1, I want those in the back. So if there are like say two more numbers, 7, 8. So I want 2, 4, and 8 up front, 3, 1, and 7 at the back. So in this scenario, I know that when I divide by 2, I get 0 for these numbers, 2, 4, and 8, which I want in the front. And I get a remainder of 1 when I sort 3, 1, and 7. So I can just sort it based on um, this number. So I can do a sort, but I can't sort it like if I just sort this array and then do nums, it would actually sort it based on like the lowest to the highest. So I'll get 1, 2, 3, 4, 7, and 8. I don't want that. I want to be able to change the key with which this is being sorted. So what I do is I add the value key that we wanted to use, and within the lambda function I say like um, whenever the value is x, I want to sort it based on x percentage 2. That is, for even numbers it will sort it based on 0. Obviously 0 is less than 1, so it will put it up front, and if it's 1 it will put it in the back. So if you want to reverse this, you can just add 1. Say you want odd numbers first and the even numbers later. Okay, let's first do this. So in this scenario, what it would try to do is it would put all the even numbers up front, 2, 4, and 8, and then it puts all the 3, 1, and 7 back, because this value from the lambda function for these was 0. The value for these in the lambda function was 1. So it put all the ones with zeros up front and all the ones with 1 in the back. What if I wanted the odd numbers up front? So I would just add 1 here, or so I want the odd numbers up front, um, and so I can change the order. Um, so but by setting the reverse flag equal to true, I believe that will um, solve the question that they're asking for. Yeah, so 317, 248. So if they want the odd numbers up front, I can just use reverse equal to true to pull all the odd numbers front, and reverse whatever we needed to do. Let's say um, I want to like work with certain operators. I want to use certain functionality that Python automatically provides. And I want to like build my own classes, but I want my classes and the methods in my classes to actually do whatever um, Pythonic classes do. So in those scenarios, I would be able to use something called magic functions or Dunder functions. So Dunder functions are just a short form of double underscore functions. So you must have seen these functions or heard of them whenever you've gone through certain Python examples. And the one thing that somebody taught me early on was to always look at the source code. So whenever we look at an int or a string and you want to do some string manipulation, the string libraries that are available from Python are already available to you publicly to be viewed. So you can go in and look at the code logic that it does. So when you look at those, typically see a lot of Dunder functions. Um, so what are these Dunder functions? What do they do? Whenever you see like these double underscore functions like add, so it has double underscore add, double underscore. Those are called Dunder functions. A Dunder function or Dunder method, what it does is it um, it is a it's a contract that is implemented, and the Python interpreter would know how to use those. For example, when we want to use operators such as plus, minus, um, and multiplied by, greater than, less than, greater than or equal to. So those are functions, those are operators that you use all the time. Say for you have two integers, 2 and 3. You always you've always used x plus y or x minus y, and you've always gotten the result. But behind the scenes, what Python did was the interpreted when interpreter looks when you look for a add, it looks for this function, and when you subtract, it looks for another function. I don't know what the name of it is, but it looks for another function. When you do a product, it does that, but internally it calls another method which has double underscore. So let's consider add. So whenever you call the add function, or the add operator, Python automatically goes into the integer. So these two are integers, and we're using the operator plus. So it goes and looks at the integer class, and within the integer class, it looks for the add method or the add function, and that is the function that provides like what it needs to get done. So here let's try doing the same thing, x add y. So we're calling x, which is an integer, and then within the integer class we're calling the add function, and then we're passing the parameter y. So that's what Python does internally. So if we do that, we get the same value as x plus y. So these are what Dunder functions are in Python. So it kind of um, you're able to redefine the operators for your classes. So int is a predefined data structure. Say you're building a class like a person, where it has a first name, a last name, an age, uh, employee ID or a person ID, um, and then date of birth. It has a lot of attributes and the multiple methods. How will I actually check if person 1 and person 2 are the same? Like we can't just say person 1, like say I have a class person, and within person I have say name and say age, age. So we have these two things within a class person. If we want to like add, if you want to check if person 1 and person 2 are the same, and if we define two different persons with two different names and two different ages, how will we actually check these two people are same? So the way we do that is, here we define a Dunder function called equal to, and then within this we provide the logic to check if their name and age and ID are same. If name and age and ID are same, then return true, right? then we return true. If not, then we return false. So if the name is different or the age is different or the ID is different, then we return false. So when we define our own class and we create objects for those classes, if you want to check equivalency greater than equal to, if you want to convert that into like if you want to add two persons, in this case it doesn't make any sense to add two persons, say, but we have two classes where we have an operator that we do, um, like addition, subtraction, multiplication doesn't actually mean anything when it comes to two different persons. um, so we wouldn't use it, but we would definitely use something called an init, which is an initialize, which I will just cover in a couple of minutes. But so say if you want to use if you want to define a class and you want to use any of these operators, plus, minus, greater than, equal to, double, equal to check equivalency, we'll have to define, say for example, to define greater than or equal to, we'll have to define this Dunder function, and to check if something is equal. So if we want to check person p1 is equal to person p2, this would actually go to the class person and check if there's actually a double underscore equal to function defined, and it will use the logic here and return true or false based on what gets returned within this function. So this might have all the logic, and that's what this operator of equal to will do. And greater than equal to, like if you define something within, if you use this operator greater than equal to, and you have an if condition here saying if p1 is greater than equal to do certain things, the Python will go into this class, which is a person class, and then look for the greater than equal to method, and then it will return this is going to return true or false based on certain conditions. And if it returns true, then this if condition is satisfied, then this goes on. So that's how the Dunder functions are used. Let's look at certain examples. So the directory function of int, or let's say string here, here we were using int, so I was using int, but let's try the directory function of string. What it does is it provides a list of all the methods that are available. So if you look at this, the string class has multiple methods within it, like add, class, directory, the dir, equivalence, greater than equal to. It has a format method. It has a greater than. It has a init. It has a hash. It has a iter. So it has multiple Dunder classes, and these are classes that are like you can actually convert it to upper case, you can convert it to title case, you can swap case. So these are not Dunder classes. So to filter them, I just quickly used this code to check for the ones that start with underscore. So if you look at this, the string has these Dunder methods, and int as well. So if you look at this, let's look at say a list. List has almost this similar type of add. So this is what has the logic to add two lists. So this method would actually have the logic to add a list 1 with list 2 when you use the add operator, and the greater than operator, the greater than equal to operator, checking for equal lists. If you want to check list 1 and list 2 are equal, So it comes back to this and it checks that. So whenever you use the equal to operator and say if L1 list 1 is equal to L2, it internally goes and looks for this Dunder method and uses that. Okay, so those are a lot of examples to understand. I think this gives us to where we understand Dunder methods. Let's see where we start using it. So this is a string. So in a string name, we're going to call the len function. So whenever we call the len function, it actually internally calls the underscore len function, and then it provides the output. So whether I call len of name or whenever I call underscore len of name, um, name dot underscore len underscore. So if I do this, it's equivalent to len of name. Let's try that out. So it has to have 4. Now it's going to change the length to be 8, and that gets calculated the same way as len of name. Another thing we look at is a list. So when we have a list and when we call numbers dot length and numbers, so let's say this has a couple of more elements, 6 and 8. That means this has a length of 1 2 3 4 5 6 7. When we call the underscore length function, or when we call the len of this, we should be able to get the actual length, which is 7. So sometimes we use Dunder functions without even knowing that we use them. For example, whenever we call the len function, we are using the Dunder function, we just don't know them. Whenever we add a couple of strings, couple of lists, we are actually calling Dunder functions. We just are not noticing that we're calling them. In fact, look at whenever we're calling a string or list of element and we say I want the first value or the second value in the index, so I want to get this value. When we do that, it actually goes in and finds the get item, and then it uses the parameter 2 that we provide, and then it does that. So if you look at that, it has to provide the value 3, or let's make this 35. Execute that, then try this. So it provides the value 35, but internally this is what we call, but internally this is what your interpreter goes and does. Because when you look at the list source code, you'll be able to find that whenever you use this, it has to go in and look at get item. So the interpreter knows to do that. So when you build a new class, you can define these things like get item, set item, and stuff like that. Those are things we typically use as well. Apart from the init that we use, like init is the one you'll use all the time. Whenever you build a new class, you will build it along with an init. So you'll always do that. So let's look at that. So here we were looking at points. Let's define a class called point, and it has two parameters, x coordinate and y coordinate. Initially, I'm just not having any values to it. I define an init class with some defaults, Um, in the init class, all I do is I provide the value x that that gets set up when somebody calls this class, and then I set the y coordinate as well. So all I do in the init is to do that. In addition, I'm also making it not mandatory for somebody to actually provide the x or y coordinate. If they don't provide it, it just becomes 0 by default. So that's all I'm doing in addition to actually for somebody to provide x and y coordinates. And then if I want somebody to be able to check if, let's start with this. Um, let's start with the equivalence. So if I want to check if 2 points are equal, so what I want to do is I want to have a point P1, which is phi 1, and a point P4, and I want to check if it's equal. So I want to check if these points P1 and P4 are equal. So right now all my code does is there's a class function. It has a init method defined where it, in case x and y are not passed, it provides default values. And it also has a dunder function for equivalency. So whenever somebody calls double equal to, it goes in here and does the logic here and then returns if it's true or false. So what this logic I have put here is whenever both the self and the other have the same x value and the self and the other have the same y value, then I return back that it's equal. So I return true whenever both are equal. So that's why I have an AND condition here. So let's try this. So whenever I pass phi 1 and phi 1, it becomes true. If I change this to phi 2, it becomes a false. Or if I change this to 1 5, it still is a false because x 5 and 1 are not equal, 1 and 5 are not equal. So that's kind of the logic that you can use for equivalency. Let's say I try to print the string of P1, or let's do this. So say I want to print P1. So currently what happens is P1 is actually a point object of the class point. What will happen if I print that object? So it actually provides the class point object with the class point, and it's at this memory location. So it does not actually provide something that's machine readable. So if somebody goes in and prints this object, they would not be able to see anything. That's where the str dunder function comes in place. One second. Okay, let's continue. So that's where the str function comes in place. So when we define an str function, so what we're doing here is I want to print something here. So I'm just printing the value with x and y, and then I'm saying the coordinates are these, or I can say x, y is this, right? So when I print this now, because it has a string dunder function, it actually uses that and it prints this instead. It does not um, actually print the memory location, or it doesn't say it's an object of the class point. It actually prints whatever is returned from the str function. In this point case, addition makes a little bit of sense. So let's see how we can use addition and implement this in here. So in this case, what I'm doing is I'm adding the value of x to the new value of x, and I'm adding the value of y to the new value of y. So whenever somebody points a new object p2, um, it takes a self value and adds the p2's x value, and for y it does the self value plus the second points y value, and then it returns xy um, as a new point. So it creates a new class point with the new value and then returns that out. So say if I want to add p1 and p4, so if I want to print p1 plus p4, what that would do is it would add this x coordinate and this x coordinate. It will be 6 comma 6, I believe. So that's what this does. And so whenever we want to implement a Dunder function for add, string, equivalency, do greater than equal to, and other things, you like typically init function is done all the time. So this is something you'll start with even when you're building your most basic classes. You'll do that. That covers Dunder functions. As we spoke about in the start of the class, we have a few more things that we'll cover in the next uh, class. But for today, that's all. I hope I can talk to you all guys in the next class. Thank you so much for joining. Bye bye.